This is the story of people who want to, who have to talk to each other as they carry out their studies of the sea. They are scientists who live with the frustration caused by great distances and time zones as they attempt to work closely together in the common cause of understanding the role of seagrasses in ocean ecosystems. The urgency of their investigations can best be summarized by Dr. Peter McCroy, director of the Seagrass Ecosystem Study.
Mostly unloved and nearly unknown, seagrasses occupy the shallow waters of nearly every ocean of the world. In many coastal areas, these plants form great meadows that stretch for miles and miles in the shallow seas. Seagrasses range from the tropics to the Arctic. The associated food webs of these systems involve everything from the most creepy crawly invertebrate to manatees, dugongs, even sea turtles, as well as waterfowl, and of course many species of fishes, commercial and otherwise. Seagrasses and their associated ecosystems are threatened on a worldwide basis. The types of pollution that they face are many kinds, everything from direct dredging and filling, the complete elimination of current seagrass ecosystems, to subtle kinds of chemical pollution. We are now facing the possibility that seagrasses could even be eliminated before we know what this means to the sea as we now know it.
Urgent, exacting research has stressed the need to share ideas and problems, but the study area is spread over much of the Western Hemisphere. Conventional means of communication proved to be inadequate, so these seagrass investigators created their own information analysis network. They call it DEAN, D-E-A-N, Digital Environmental Analysis Network. Working together as a group requires the sharing of both ideas and problems, collective thinking.
Levette, would you get Dr. Ronald Phillips, Seattle Pacific College, please?
Yet staying in contact is often very difficult. Time zones, conferences, scientific fieldwork, university classes combine to create brief time windows when one busy person can reach another.
I'm sorry, Dr. Phillips is doing underwater research in Puget Sound. I'm sorry, Dr. McCroy is teaching a class.
This is Dr. Patrick Parker, University of Texas. He has just heard of a patch of unusually warm water which has developed in Mexican waters. If he can get samples of seagrasses and temperature measurements soon enough, it will be a valuable addition to his research. To do this, he needs to have his program manager in Washington, D.C. obtain cooperation from Mexican colleagues.
Mr. Holt is in a meeting. From there, he is going directly to the airport.
But his program manager's time window is closed, a missed opportunity. In Seattle, the phone of Dr. Phillips goes unanswered. He is monitoring the progress of a seagrass garden in Puget Sound. He has successfully planted seagrasses from different regions of the United States into Puget Sound to test their ability to survive in a new environment. Dr. Phillips has just heard of a new electrical power generator that will increase the temperature of river water. This temperature change may affect the seagrasses growing where the river empties into Puget Sound. His research may be helpful in preserving the seagrass. To be effective before it is too late, he needs help from the other members of the research group. So let's stop right here and see how the group can avoid the problem of closed time windows. At the University of Hawaii, Dr. Kent Bridges has been writing programs which use a centrally located computer for the seagrass analysis study. Any member of the group can run the programs by using terminals which link to the computer through standard telephones. This network functions in several ways: as a storehouse of data, as a way to run data analysis programs, as a source of bibliography information, and a variety of project management programs. Our seagrass investigators need a sure way of communicating. With the right kind of programming, the network and its computer can also serve this function. Okay, let's put it to work. Dr. Parker is in limbo because he tried to reach his program manager by conventional means. Let's back up and try it a new way. He has again used the telephone, but this time he coupled it to a terminal that fed his request to the computer. The odds don't seem much better. His man is now in the middle of the Pacific Ocean and 5,000 miles further away. But now there is one major difference. Dr. Parker's urgent request for an expanded permit is stored in the memory bank of the computer and can be immediately available by a command from the appropriate network member. Contact to the computer is made by calling a local telephone number and linking the telephone receiver to a terminal. A variety of terminals is available. This model can be connected to a television set. The recipient reads his messages on the television screen. Contacts are made to the International Decade of Ocean Exploration colleagues in Mexico, and Dr. Parker can now make his collecting trip in time. Now we can apply the network to Dr. Phillips and his investigations. Seagrass transplanting is a proven success. Some colonies appear to be better than others at standing temperature variations. Back on dry land, seagrass investigator Phillips needs to determine the best colony to live in the warmer environment. He uses the message exchange network by dialing the local telephone number to contact the computer. Dr. Phillips types his identification code and the computer responds by sending all of the messages which have been stored for him since his last contact. He can then send messages to one person or to a group by typing some simple codes. Dr. Phillips needs the cooperation of the other scientists. He transmits his needs, ideas, and questions, and the chain of collective thinking begins. His message is simple. New power plant will cause temperature increase in Puget Sound at the river entrance. Plans underway for transplanting. Need thoughts on seagrasses for testing in a wide range of salinities. The first recipient, Dr. Calvin McMillan at the University of Texas, responds with the desired salinity information and starts the chain reaction involving all of the seagrass investigators. Dr. Jay Zeman of the University of Virginia relates details of an existing study of the effects of waste heat. Doctors Robert Wetzel and Michael Klug at Michigan State University provide valuable detritus information. In Hawaii, Dr. Bridges notes the original request and input from other team members, then contributes a computer-generated worldwide atlas of the desired species of seagrass. This entire flow of collective thinking was initiated by Dr. Phillips' one request for information on the species Zostra marina. An ideal sample of the species would be from Mexican waters. It could be expensive and time-consuming to collect in this remote area. But this Mexican coastal site is where Dr. Parker of the University of Texas is doing his research. He arrived in time to complete his water temperature studies and can now take time out to transmit a progress report before collecting seagrass samples. Also, messages from his office may be waiting. Following standard procedures, he checks in, and there is the Phillips message. Zostra Marina grows profusely in his study area, and it is easy to collect additional samples for shipment to Puget Sound. Being away from the desk is the first love of every natural scientist, and close contact with the other members of the research group can now be easily maintained. The real story of this network is the philosophy of the scientists who are using it. Today's world of research does not have room for just the cloistered scientist, with the rest of the world waiting for his journal to be published. These seagrass scientists value the nowness of sharing their findings and ideas. This network, as a research tool, has helped to open their time windows. We have seen just one facet of the Dean system. Studies are continuing to help these researchers apply their science to the betterment of the world we live in. This is another of the research projects supported by the National Science Foundation as part of the International Decade of Ocean Exploration.